I think we are alive. Axel, I'm gonna do a presentation, a quick presentation in Portuguese, and then I'm gonna do another one in English, and uh, and then you can start actually your presentation. All right?
All right.
Uh, Boa tarde, pessoal. Meu nome é Carolina. Sejam todos bem-vindos ao segundo workshop de Pegmatitos. Bom, o principal objetivo desse workshop, como a gente já fez na primeira edição, é reunir um grupo de pessoas, né, que compartilham da mesma paixão e interesse em relação aos pegmatitos e seus subprodutos. Faço parte da organização de um grupo bem grande, a Flávia ela está nos bastidores, e ela está com vergonha de aparecer, mas nós estamos extremamente felizes em ter conseguido reunir tantos profissionais de excelência nesse segundo ano para um evento ainda virtual, que tem como intuito, né, a divulgação e a troca de experiências e conhecimentos. Esperamos que a terceira edição, né, aconteça de forma presencial e que assim a gente consiga nos encontrar em breve. Eu gostaria de agradecer a presença de todos os palestrantes e parceiros, o apoio da UFOP-SEG Student Chapter, o DGEL, a pós-graduação da UFOP e a UFOP, assim como todos os institutos, as universidades e as empresas que compartilharam o nosso cronograma. Muito obrigada. E antes de iniciarmos, eu vou deixar claro aqui que eh, gostaria de avisar que, ao final da palestra, será enviado um formulário para o preenchimento e recebimento dos certificados. Perguntas e dúvidas serão lidas no final da mesma. Now I'm going to do the presentation of Axel Müller. Um, as I was saying before, Axel, I'm very, very happy and pleased to be here with you. And as I said before, we are a small group of Brazilian research that share interest in pegmatites, and we are now in the second edition of this workshop. And because of the pandemic, it's still a virtual workshop, but um, hopefully soon on the third edition, we are going to have the present and we are going to be getting to know each other in person. So Axel Müller is a geologist, graduated at the Mining Academy of Freiburg in Germany. He also got his master's and doctorate degree at the University of Göttingen in Germany. Since 2012, he is a research associate of the Natural History Museum of London, and since 2015, he is a professor of mineralogy at the Natural History Museum of Oslo. Um, Now I'm gonna pass the microphone, virtual microphone, to you, Axel, and I hope you have a nice time here. And at the end of your presentation, we're gonna have we, if you want and if you are available to, we can answer a few questions, and yeah, you can uh, say anything you like now.
Okay, thank you very much. First of all, I like to thank you, the Brazilian Pegmatite Research Group, for the invitation. So my name is Axel Müller. I am professor at the Natural History Museum of the University of Oslo in Norway. And today I like to explain you our pegmatite exploration project, which is supported by the European Commission by 9 million euros. So the topic of the presentation and the project is GREENPEG, exploration for pegmatite minerals to feed the energy transition. On this slide, you see a very short fact sheet about our project. So the official title is GREENPEG, New Exploration Tools for European Pegmatite Green Tech Resources. This program is sponsored in the frame of the Horizon 2020 Climate Action, Environment, Resource Efficiency and Raw Materials program. And the project is an innovation action program. So it means it's not a purely research project. It's a very applied project where we have to deliver, let's say, application and technical developments and the readiness level of 6 to 7. That means a lack of prototypes. And the project started in May 2020 in the COVID period, which was a bit challenging. And we continue until October 2024. And the total budget of the project is 9 million euro. And I'm the coordinator of the project, and Claudia Loré, my colleague, is the project manager. You can also find us on the GREENPEG EU website with the newsletters and so on, and other information about the project. In this slide, you see all the partners in our project. There's 13 partners. 5 of them are academic partners, and the other ones are exploration companies or non-profit companies, which are quite comprehensive consortium to solve the problem how to explore pegmatites which are hidden under the surface. Also, the map on the left. Yeah.
I'm sorry for the interruption. Can you just please click on the hide on your screen for us to yeah, okay. Thank you. I'm sorry.
Yeah, that's fine. On the left, you see the map. In green are all the countries, the European countries, which are involved in the project. So there are 8 different countries, these 13 partners. So the target of the project are critical raw materials, in particular lithium, silicon, rare earths, beryllium, and tantalum for the green energy shift. And these elements are, among other deposit types, enriched in pegmatites. So as specialists of pegmatites, you know that pegmatites are relatively small rock bodies compared to other rock bodies. However, they occur in large numbers in pegmatite fields or clusters in Europe, of course, elsewhere in the world too. And they are very hard to discover if they are hidden below the surface because of their small size and other properties I will explain you later. So the general objectives of the project are to deliver new instrumental exploration techniques and devices. These are, for example, a piezoelectric sensor, a helicopter complementary nose stinger magnetometer, and the drone-borne hyperspectral imaging system. And then we also will deliver several data sets, for example, petrophysical properties of pegmatites, and also workflows how to explore for specific types of pegmatites. And as you probably know, on the right, you can see a large spodumene crystal. Unfortunately, this is not in Europe, this is in the US. And spodumene is at the moment the most important hard rock source of lithium, which covers about 40% of the lithium production at the moment. Here's again the list of our target elements on the left, which we target in our pegmatite exploration approach. And in the middle, you see the most common elements, pegmatite minerals, in which these elements are enriched. And on the right, here are some icons for their applications. And for the green energy shift, we need, in particular, lithium for energy storage devices, silicon for solar panels, and rare earths for the magnets in wind turbines. So these are very crucial elements we need to aim the targets of the renewable energy production. These 6 diagrams show you the production of 6 different elements, which I just named before in my table. Lithium, silicon, and so on. And you see on the x-axis, you have the year of the production or mining production. And then the green line is the worldwide production of the particular element. And the red one is what is produced or mined in Europe. As you see, except for feldspar, most of these elements have to be up to 100% imported by the European countries, making the European economy very dependent from this import of these elements. And to change this would be good if we have or can open some mines within Europe, first of all to secure the supply chain of these elements, but also to limit the transport and therefore the CO2 emission of large amounts of ores across the globe. Yeah, here you have the first pictures, how the pegmatites in Europe look. Here on the bottom, for example, from northern Norway, a pegmatite exposed in an open pit on the left, sitting in a grayish granite. I come back to this later. So the general approach, the methodological approach of the exploration toolset development within the project bases on the specific characteristics of the target pegmatite ores. These are low contrast of the petrophysical properties compared with the wall rocks, which makes it very difficult for geophysical exploration methods. Then pegmatites have a high mineralogical variability within the pegmatite bodies, but also among different pegmatite types, which makes it, again, very difficult because in each area, exploration methods have to be adjusted. On the other hand, or third, pegmatites are relatively small ore bodies. The good point here, number 4, is that the pegmatites occur in clusters. So theoretically, several pegmatite bodies can be mined at the same time if they are close to each other with the same equipment. And fifth, the existence of lithochemical halos of certain elements around pegmatite bodies. These geochemical halos actually make, in a indirect sense, the pegmatite bodies larger for geochemical exploration methods, which I will explain you later on. So the impacts of our project are the exploration success is hopefully the major outcome of our project to increase the European resources of the named elements. However, we will also increase the awareness and acceptance of exploration activities in the society, which is also a challenging topic in general, because the European society at the current stage is very not flexible if it comes to opening new mines or exploration activities, which has several reasons. And we like to improve this acceptance too. At the same time, you would like to reduce environmental and social impacts of the exploration activities and, of course, the costs and the CO2 emission. Now, a bit more to the facts. So our project approach in the field is the methodological approach. So it's subdivided into 3 different scales. So that's the province scale exploration, the district scale exploration, and the prospect scale exploration. So in the table here on the right, you can see what it means, province scale, in the terms of size of the prospecting area. On the left, this approach is schematic illustrated. That's our GREENPEG logo, if you like. And the table lists here the major methods which we test in 3 pegmatite fields in Europe for the exploration, for the different scales. I don't want to name all these exploration techniques now, which are named here. I will explain you later on some of these methods which we apply in 3 demonstration sites, and then you will get a better idea what it's about. It's a bit information, too much information in one slide here. So in addition to this, we like to develop 3 prototypes of equipment, if you like. So that it's first a piezoelectric spectrometer, which uses the piezoelectric effect of quartz to explore for pegmatite bodies in the underground. It's a method which has been applied in the 1970s, especially in Russia. However, the method has almost been forgotten because pegmatite exploration was in the last 50 years not so important, and for several reasons. So we like to redevelop with a new knowledge and new technical possibility, this prototype. Then we develop a hyperspectral drone imaging. So we do also pegmatite exploration with the drones. And then we like to develop, in particular, industrial partner called TerraTech, a partner in GREENPEG, a helicopter compatible nose dinger. This has not been certificated in Europe yet. So such things exist only in Canada, certificated, and Canada is renting out this equipment around the world. However, in Europe, we like to have our own one. Usually, this nose stinger, or the equipment which is in the nose stinger, it's hanging below the helicopter, about 30 meters below, which is a certain danger, especially if you explore in areas with very high morphology. And now about our 3 exploration test sites. So the map on the left shows you the locations of our 3 sites. So one is in northern Norway called the Tysfjord area. The second one is the Leinster area in Ireland. And the third one is Wolfsberg in Austria. So these 3 fields, pegmatite fields, have been selected because these are exploration green fields. That means exploration or even mining is going on already in the sites, and they are therefore very suitable to test the named methods. And they are also in different landscapes. So we are in northern Norway, we are in an Arctic landscape, very mountainous. In Ireland, it's a very relatively flat, hilly farmland, and the Wolfsberg is the highly vegetated Austrian Alps. And here you see already some pictures. So I think in the next minutes, I go now a little bit in the 3 exploration test sites in the terms of geology, so that maybe it's most interesting for you, so that you learn a little bit about the European pegmatites. So first we go to the northern Norway Tysfjord demonstration site. The geological map on the left shows you the area of the Tysfjord, which is in north-central Norway, which is shown here on the right in this little inset. So we are relative north in Norway, south of the Lofoten Islands, which are on the left map up here. And there's a tectonic window, the pinkish area, which is covered by the so-called Tysfjord granite, which is a Paleoproterozoic granite. And the red dots here are huge pegmatite bodies. There are about 25 in the area. For Brazilian status, it's not much, but the pegmatites are quite big, I can tell you. So in the scale of the map you see here below, that's 10 kilometers. So the pegmatite field is about 70 kilometers in north-south direction and about 50 kilometers in east-west direction. And the landscape looks like this. So this is Statin Mountain, which is in the middle of the pegmatite field. So the morphology can be quite challenging in the area in terms of applying exploration. So the pegmatites actually have been mined since 100 years for feldspar, for the porcelain or ceramic production, but we are not untouched the last 50 years until about 2000 or 1995 to be precisely, when they discovered that the quartz in the pegmatites has a super pure quality. It's the second best chemical quality of quartz in the world. And mining was reactivated. Here on the left, you have the intermediate zone of the pegmatite. Here's a person that you get an idea about the dimension of these pegmatites. So these pegmatites, because they are Paleoproterozoic, that means they are 1.7 billion years old. They underwent deformation about 400 million years ago. So these are, in a strict sense, meta-pegmatites. So they are deformed, as you see, the wall zone of the pegmatite, where you would expect granophyric growth zones. This is a müllerite, basically. And also, if you look in the quartz core, for example, here shown on the right, you see this quartz core is actually shear lenses, boudins, within the pegmatite body. So the pegmatite has been reworked metamorphically and then tectonically after the crystallization. That you see also in the minerals, which is a little bit a pity, because here on the upper left in figure A, you see a 1 meter size beryl crystal, but it's completely sheared. the crystal shape is not preserved and it's partially altered or recrystallized as phenakite, the white bloods. These pegmatites are quite also radioactive, so they contain thorite, allanite up to 1 meter in size, and also petrogite, which is a very rare earth element mineral. And here you have an air figure of one of the pegmatite mines, and on the right, and on the left you see a geological map. So the air picture shown on the right, it just covers the eastern side of the pegmatite body. So the pegmatite continues under the granite host rock and comes out about 300 meters away again in some other quarries. So it's quite a huge pegmatite body, about 400 meters in length and 300 meters in width. And here's a focus in the geological map, if you like. There's an area around the village Strak where there are about 18 pegmatites exposed at the surface. And one of these or two of these pegmatites are mined underground. Here you see a picture of the underground mine. And the mine, what they mine, that's the quartz core. You see the quartz core are quite big, up to 80 meters in diameter, just quartz. And the special thing here, the quartz quality, it's superior. It's very high. And they have also a huge quartz processing plant in the area. Just in the background, you see this village here. There are also the pegmatite mines. So this plant is just 1 kilometer away from the pegmatite mine. Yeah, here are some other pictures of. They have also another mine here. It's called the Jennyhaugen mine in the pegmatite. You see the intermediate zone of the pegmatite in the background. So also a younger generation of pegmatites, but they are much smaller, but they are quite beautiful, completely made out of amazonite and quite rich in tourmaline and beryl. But these have no economic importance, the pegmatites. These are too small. And we dated these two types of pegmatites, the old ones, which are mined, which are 1.7 billion years old. And the younger ones, actually, the amazonite pegmatites, are 400 million years only. So we have two pegmatite generations in one pegmatite field with almost the same mineralogy. Both pegmatite types are NYF pegmatites. And until we dated them, we didn't know the age difference between these pegmatites is so huge. Yes, it has just been recently published, the age of these pegmatites, if you are interested. Coming now to the Leinster site in Ireland. That's our second demonstration site of exploration methods. Here are explored about 22 lithium pegmatites with about 1% of lithium. The area is located south of Dublin on the eastern coast, now close to the eastern coast of Ireland. Here is an enlargement of the geological map. You see here's the scale, 20 kilometers. And the stars are the spodumene pegmatite. And all occur close or within a granite body, Leinster Badolith. But they are connected to the East Carlow Deformation Zone. So it's still under discussion if these pegmatites are partial melts or restitic melts of the granite plutone, or are they anatectic melts reactivated or partial melted during the shearing activity of this major fault zone. Yeah, and here on the right you have one area which is here down in the south. It's a detailed geology. You have a scale and a drill hose and a location of one spodumene pegmatite. In contrast to Tysfjord, these pegmatites are not exposed at the surface. They are only known by boulders found in the fields, and based on the boulder mapping, they located the drill core as the drill holes, and then finally they managed to discover hidden lithium pegmatites below the surface. And these are some samples, pictures from the field in Ireland. So on the left, it's Julian Manouk, the partner or a major researcher, let's say, working on these pegmatites. And you see in the boulder, a pegmatite boulder in the wall of the field, and the big spodumene crystals, these white stripes. So the spodumene crystals, if you find a spodumene pegmatite boulder, they are quite rich in spodumene. And here is John Harrop, exploration geologist, responsible for exploration in the area. And you see also a nice boulder with a relatively large spodumene crystals here. And however, most of the pegmatites are only known from drill cores, where you have some examples. And here a drill core with some spodumene. And the vegetation there, it's either fields, farmland, or quite dense forest. The third from the demonstration side of the exploration methods we apply is the so-called Wolfsberg deposit. The Wolfsberg deposit is located in the Eastern Alps. So here in the small map, you see a simplified geological map of the Eastern Alps with Vienna here in the northeast and Munich here on this side, and then the Wolfsberg deposit is the red dot here. So it's not far from the city Graz. The larger map here shows you the underground mine projected to the surface. So there has been lithium pegmatite mined in the 1980s for some purposes. And the pegmatites are basically only exposed in the mine. So this greenish lines here and the pinkish lines are pegmatites. So this pegmatite shape is very different than those to the Tysfjords. These are pegmatite dikes, several hundred meters long, very straight, more or less very straight, and between 2 and 10, 12, up to 15 meters wide. Here on the upper left, you can see a cross-section to this part of the mine. You have two host rocks, green the amphibolite, and the brownish one is the mica schist, and you have pegmatite dikes, spodumene pegmatite dikes in both rocks. Yeah, so this is the landscape in this area. So as I mentioned, there are also no outcrops of the pegmatite at the surface. However, you find pegmatite boulders with spodumenes in the field or in the forest, like here. And here on the right, you have a picture from the underground mine, where in this case, the edit followed the spodumene pegmatite, which is here between 2 and 3 meters wide, but several hundred meters long. And here, example how the spodumene looks in the boulder in the field. Okay, coming a little bit back to the approach of the GREENPEG project and the methods which we apply. I should also mention that our exploration approach bases on a new model of pegmatite formation, besides a known one, which is illustrated here in this figure. On the left side, you may have seen this figure. It's from Czerny, a classical, our godfather of pegmatology, if you like. He developed a model how the chemical distribution of pegmatites is within the pegmatite field. You see here is a parental pluton, which here is a scale between 1 and 3 kilometers, and the dots are representing the pegmatites. And the farther you move away from the parental pluton, so more enriched become your pegmatites in lithium, cesium, and other incompatible elements. So this model has been developed for pegmatite fields which are related to granite plutons, where the pegmatites represent residual melts of the plutons. However, in other areas, or in some areas, let's say, this model seemed not to work very well. In the middle here, in figure B, you see an example from Norway. You have a granite pluton in the north of the pegmatite fields. All the red dots are pegmatites. And then you see the lithium content in the quartz, which reflects the fractionation degree of the pegmatite. Compared to the left pictures, this pattern of the pegmatite fractionation is very erratic. It's irregular. It doesn't seem to be connected to the granite pluton somehow. And what we did then in 2015, we dated the granite and the pegmatites, and it turned out the granite is about 70 million years older than the pegmatites. So even the granite, Pluton, and the pegmatites occur next to each other. They have basically nothing to do with each other. The age gap of 70 million years is too big that that could be genetically related. They're basically not related. And that's therefore we have to rethink the model by journey, which of course applies to some fields. Because for exploration, it's very important to find the lithium-enriched pegmatites, of course. But if you have such a erratic pattern, you need a new model. And a different situation again is in Leinster, where I already explained to you that the spodumene pegmatites occur exclusively along a larger shear zone. Yeah, and this we try to understand by putting all in a more complex model. So you have on the right the classical models by journey, where the pegmatite melts originate from granite plutons. That could be either S-type plutons forming LCT pegmatites, or an A or A-type plutons which form NYF pegmatites, such as in the case of the Tysfjord pegmatites. However, there are obviously pegmatite fields which are created by partial melting of either amphibolites or metasediments, and for this you don't need a granite pluton. So the difference here is they are formed in much greater depth and they have no parental pluton at all. So that has a number of consequences for the exploration. Okay, coming back a little bit to the exploration methods we apply in the GREENPEG project. So I start with the province scale, the large-scale exploration methods, which is basically remote sensing. So I put here some figures from colleague Santos, from one of our GREENPEG partners from the University of Porto. So they do the remote sensing approach in our project. So on the left side is shown several bands have been chosen from Sentinel-2 satellite images to detect the known pegmatites. So here's the Tysfjord pegmatite field, or the green area with the Atlantic and the lakes, if you like, in blue. And here is the example, a zoom in this blue square here, where you have the Jenihaugen pegmatite mine, a known pegmatite, and they, with the spent separations, they could confirm or adjust the method to detect pegmatites with this remote sensing approach. So the left side is done on the known pegmatite bodies. On the right side shows you the same area, where they, with this method, identified possibly new pegmatite outcrops. So this we have not confirmed these outcrops yet, because this is very new. You see, it's just published. So next season we go in the field to see if the satellite image prediction, in our case, works for this approach. And how this works is a little bit shortly explained here. So the Portuguese team, they take spectra of pegmatite minerals, and then also takes the bands, these same emission bands from the satellite image, and compare and try to adjust the best way to get the bands which correspond more or less the spectra of the pegmatite minerals, to get the best out of the satellite image treatment. That was in very simple words, but you can read, of course, the publication. So now I go down to the district scale exploration. That means basically airborne geophysics. So this is a radiometric map of the Tysfjord area in northern Norway. So you see the scale, it's here 500 meters. So the area covered by this radiometric map, which is basically the gamma radiation of the surface, which covers maybe 3 times 3 kilometers. And the yellow dots here are the open pegmatite mines. And you see that the radioactivity around these mines is significantly higher than in the surrounding area. So that means these pegmatites have a radioactivity which can even detected by high-resolution airborne radiometry. So that is actually the first time that has been done for pegmatite exploration. So that is a very important result of our project. And interestingly, we have some anomalies where the question marks are. There are no pegmatite mines. So the chance that we find pegmatites below the soil here are quite high if we consider that this correlation of pegmatite mines and radioactivity is correct. So that is already one major output of our GREENPEG project. Another approach we apply, it's a so-called trace element in quartz mapping. So that means we collect quartz from each pegmatite and analyze it with laser ablation mass spectrometry, which I will explain in the next slide. The challenge is here that the pegmatites are chemically zoned, and that applies also to the quartz. So if you sample quartz from a pegmatite, it's very important to take aware or to register from which part of the pegmatite you take the quartz, because the quartz chemistry across the pegmatite changes. So if you want to compare quartz chemistries across the area, you have either to decide to sample only quartz from the intermediate zone or only quartz from the world zone to compare the chemistries of different pegmatite bodies. So it's not so easy as it maybe appears. This quartz trace element in quartz approach. On the right, you show or you see again the Tysfjord geological map simplified, and each dot represents a pegmatite, and the size of the dot is the titanium content in the pegmatite quartz, and the color depends on it's the different pegmatite types, and we also actually sampled the host granite gneiss, which is also very pure. So if you look at the concentrations of titanium quartz, they are very low. However, for the industry, it's very important if it's 10 ppm titanium or 1 ppm. It makes a big difference in the quality and the price of the quartz. You can sell it. And let's see at the next slide. Yeah, that is just who are not so familiar with the laser ICP-MS analysis. It just illustrates the method. So on the right is here a backscattered electron image of the laser ablation hole on the quartz, which we did. So we do a raster analysis. So we drive the laser over an area about 200 times 300 micrometer and analyze the trace element in this area in the quartz. So we have a polished thick thin sections which we use to because of the optics, we can also avoid fluid inclusions. So to make sure that we analyze only the structural incorporated trace elements, and then it's analyzed. So this shows you 2 pictures from a recent publication in chemical geology. So on the left, you have the total trace element content in pegmatite quartz, the average, for different pegmatite fields worldwide. There's also one Brazilian, the Borborema pegmatite field in green. And here trace areas is a Spanish one, and so on. So you see, if you look at the total trace elements, so that means you sum up all trace elements you analyze in ppm, and then makes the average. You see that the LCT pegmatites, the lithium pegmatites, have much higher trace element concentrations, the quartz of them, than the quartz from the NYF pegmatites. So in terms of economy, the chance to get a better quartz quality is much higher in NYF pegmatites and in LCT pegmatites. And in fact, you see the Tysfjord quartz is the most purest pegmatite quartz which we know so far in the world. On the right, you can also use the trace element content in quartz. Here's plotted aluminium in quartz against lithium to use quartz as a pathfinder for lithium deposit, because it showed if your quartz contains more than 30 ppm lithium and more than 100 ppm aluminium, that this quartz comes most likely from a spodumene pegmatite. So if you do stream sediment analysis and analyze the quartz, exploring for lithium pegmatites, you might use this approach to see if your lithium content in the river sediment quartz is higher than 30 ppm. So then maybe you can say maybe you have lithium pegmatites in the area. So yeah, that is published here. Who is interested in that? Here's now for the Tysfjord, my PhD, Hwang Su, has analyzed different pegmatite types in the Tysfjord area, and you can see for these different pegmatite types, but also for the granite host, the trace elements like aluminium. It's usually the most common trace element in quartz, and the lithium, titanium, germanium, boron, beryllium, and gallium. These are also typical elements which you would analyze in quartz to get also genetic information and also the chemical quality. Yeah, back to the map which I showed you before, the regional distribution of quartz chemistry. So here's a zoom in the drug area in the pegmatite field where we have the highest density of pegmatites. So each in this area, as I told you before, there are 18 pegmatite bodies occurring very close to each other. And if you look at the titanium content compared also to this map, actually in this area, the titanium content is lowest. It's actually the best quartz quality is found in the center of the pegmatite field. We don't know really why it's higher in the other pegmatites at the edge of the pegmatite field, but it's just a fact. So we still have to work out how it is or why it is so. So, and the good thing is the nitrofoil pegmatite, it's already the one which is mined. So by instinct, the mining companies actually mined more or less the pegmatite with the best quality. The processing plant is here not far away. And there are good opportunities to mine more pegmatites in this area, just for the quartz. So we're talking here of NYF pegmatites with high purity quartz. So now we're going down in the scale of prospecting techniques applied to discover hidden pegmatite deposits. So here we made a different approach, the mapping the soil sampling of soil above pegmatite bodies. So we choose here a test site where we know there is a pegmatite below. So here on the geological map on the left, you see a very detailed map of the pegmatite, which is in red, hosted by granite gneiss. So the pegmatite is exposed partially in an open pit, but continues under the soil and the swamp towards the northeast. And here we took our soil samples across 3 profiles perpendicular to the pegmatite body, some outside the pegmatite body and then over the pegmatite body. And this, the evaluation of the results of this soil sampling, it's still going on. It's carried out mostly by the University of Exeter in the UK and the college, the Dublin University College in Ireland. Yeah, and here you have an example here how the soil sampling looks. So we look carefully, we removed, we opened, let's say, the vegetation and took the soil samples, then we put the soil back, which we didn't need, and also put the vegetation back. So basically, after we took the samples, there's no trace that we took a soil sample there. Another prospect scale exploration approach was the ground penetrating radar. So this showed to be very successful in the case of the Tysfjord pegmatite exploration. So we got some modeling of this ground penetrating radar. The 3D bodies are shown in violet. And then in this case, we have also some old drill cores, and we could compare the drill core with the calculated bodies out of the ground penetrating radar, and they correspond very well. So that was also a very surprising good result, which was mostly carried out by the Geological Survey of Norway. Another approach is the lithochemical halo mapping around pegmatites. It has been known since maybe 40 years that the pegmatites, or some of the pegmatites at least, send out fluids into the wall rock while crystallizing. And these fluids carry some incompatible elements with them and make a metasomatic halo around the pegmatite. These elements are mostly lithium, cesium, rubidium, fluorine, boron, also depending a bit on the pegmatite type. Yeah, in this case, this is the Tysfjord area. You see as a pegmatite, the white rock here in the wall of the mine, and the host rock, the granite gneiss. And we did some scintillometer measurements, some Geiger counter measurements across this wall. And you see in the pegmatites, the radioactivity is relatively high compared to the wall rock. However, the radioactivity, it's also high close to the pegmatite in the wall rock. So that means we have a thorium-uranium halo outside the pegmatite, caused by the pegmatite. So in terms of exploration, this means our pegmatite becomes more visible by airborne geophysics because the body appears larger, the radioactive body, because of the halo. And therefore, that is the reason why we could detect these pegmatites with the airborne geophysics. Maybe you remember the map I showed you a few minutes ago. And we did also this halo mapping in the underground mine in the Tysfjord area, which shows you on the right. So the red stripe here, it shows you approximately the sampling profile. And here on the left is the result. So the green one is basically the pegmatite. And you have here the elements which we analyzed from the wall rock. So you see, for example, there's a nice halo of tantalum, fluorine, a little bit of tin halo, and so on. So this enlarges your geochemical visibility of the pegmatite if you want to explore for hidden pegmatite bodies. Yeah, and here my postdoc made a multi-parameter approach to determine all the elements which make the halos. So the list is actually much larger than we thought. It's not only lithium, cesium, tantalum. There's also niobium and uranium, thorium, which may create a chemical halo. However, this might be different for different pegmatite types and areas. So that is just specifically for the northern Norwegian NYF pegmatites. Yeah, I come slowly to the end of my lecture today. So beside all this exploration technical approach, we also have a work plan which incorporates a careful analysis of environmental, social, and safety impacts within the implementation of the new technological approach, assessing these aspects through the entire life cycle of the exploration techniques, which will be developed. So we make a life cycle analysis, which is carried out by the University of Exeter. How much emission and so on it's produced during the exploration, and what is the environmental impact by applying different exploration methods, and how this can be reduced. This is also to increase the awareness and acceptance of exploration activities by the public. And the results will, of course, established and shared with the best practices, and they will shared with the partners and with the industry to improve exploration impacts and acceptability. So the major messages of of our project are to provide the mining industry with the latest know-how to explore European pegmatites. Of course, the methods which we developed are also applicable to pegmatites worldwide. It's just because our project is sponsored by or financed by the European Commission. Some general overall aim is, of course, to increase the exploration success of buried pegmatite bodies, then to reduce the exploration costs and the exploration time, to reduce environmental impacts, especially to increase the acceptance of exploration activities in the society, to unlock more resources. That is actually a side product of our approaches. In Norway, in northern Norway, for example, we discovered most likely already 2 new pegmatite bodies. And we also contribute to close the existing downstream for the industry to provide local resources for the local processing plants. And we like to stimulate entrepreneurship and revitalize the European industry, and especially the mining industry, as for manufacturing the green technologies such as solar panels, uh, electrical batteries, wind turbines, necessary to deliver the EU Green Deal and to perform the energy transition necessary. Yeah, funnily enough, the whole project has recently published, so it's open access. So mostly what I told you today, you can read in this article, which is published by the Geological Society special publication. Um, so easy to download for free. And if you have any questions, you can contact either me or my project manager, Carla. So thank you very much for your attention.
Congratulations. Thank you very much for your enriching presentation. We have some questions. Is it is okay for you to answer?
Yeah, that's fine.
Okay. We have the first one from Ariane, and she said that you guys met in the Greenfield project by the company Conico in Helgland. She was part of the Portuguese team despite being Brazilian, and she wants to know a little bit more about the genesis of the pegmatites in the area. Uh, she wants to understand a little bit better about the anesthetic orange of the pegmatites from the region of Norway.
Yeah, it's a very complex question.
Yeah.
So, these pegmatites, yeah, they are under exploration activities by the Cunico AS, Norwegian, yeah, Australian joint venture, if you like, for exploring for battery metals. So they entered an area which has been known since a while. It's an area of LCT pegmatites,
Mhm.
which is sitting mostly in Caledonian rocks. That means these pegmatites are relative young, so most likely of Caledonian age. That means about 400 million years. However, these pegmatites have not been dated. So that is a thing, yeah, somebody has to do. As I said, these pegmatites sit in the Caledonian nappes and actually very high grade, metamorphic high grade Caledonian maps. It's actually the lower nap package just above the Proterozoic basement. So we are in the higher amphibolite phases. And there's no granite with Caledonian age in this area. So it's very likely that these pegmatites are
Mhm.
anatectic.
Okay.
But this is as long we don't have a proper age dating, it's an assumption. But yeah, I
Okay.
think maybe I partially answered the question. So to be sure, it's anatectic. It's quite
Mhm.
complex. You have to date your
Mhm.
pegmatites and the granites. You have to make sure that there's no hidden granite below the area. By then you need the gravimetric maps to work this out or measurements. Yeah, and so on. There are a lot of parameters you have to consider before you make sure what you're dealing with. However, if your pegmatites are sitting in a high-grade metamorphic rock, the chance is relative high they are anatectic. In addition comes they are not merolytic, these pegmatites. So they don't have open cavities. So that means they are
Okay.
formed under high pressure, which supports the anatectic theory.
Yeah. We have
Yeah.
some cases of similar areas here in Brazil as well, but they still need to be dated for you can actually say with more accurate and precise information about the pegmatite body. We have another one from Flavia. What set of elements can I use as an indicator for non-lithioniferous pegmatites?
Yeah, you mean now geochemical exploration for lithium
Yeah.
pegmatites? Yeah,
Yes.
Yeah, you can, as I tried to explain today, you have different types of geochemical exploration. You just can do the soil and tree sampling, which is the most classical method. Yeah, it worked out that in Portugal they are quite successful. The University of Porto, they have very experienced with soil and stream sediment exploration of lithium pegmatites. So actually, lithium, of course, is one of the elements you can analyze. It's in the soil, and yeah, probably also stream. So they have some alumides. And it's in this Portuguese pegmatites is also tin successfully used for the soil geochemical soil sampling exploration method. Yeah, in my talk, I try to explain the new one using the quartz chemistry. So you use the lithium content and the aluminum content in the quartz as a pathfinder mineral. There are, of course, other pathfinder minerals. You can also use the columbite minerals in the stream sediments to decide if you deal with very fractionated, as lithium-rich pegmatites or not. There are also some papers out there. Yeah, although if your pegmatites are exposed at the surface, you can, of course, try to get the bulk analysis, but it's a very difficult approach, especially if your pegmatites are internally zoned. Um, yes, the question is very complex. So, but it depends what of kind of exploration you mean: soil or stream sediment sampling, whole rock
Yeah.
sampling. Yeah.
The next question, followed by Flavia, was which type of prospection is more suitable for chemical analysis, stream sediment or soil?
Yeah, that depends again in your area. For stream sediment, you need a stream. Actually, in Tysfjord, we don't have a stream which is big enough to sample. So we could only apply the soil sampling. The soil sampling is obviously very important in the tropical countries where you have no outcrops at all. Um, yeah, in Ireland, we have a combined approach. They look at the boulders lying around on the surface and doing the soil sampling. There are also stream sampling has been done a little bit, but there are not so many streams. But as I know, the Portuguese groups, they are very successful in stream sampling. For example, there are the stream network and the catching area, the catchment area is quite large. So then the stream sediment approach is quite, can be applied very well.
Okay.
So it's again about your local situation. It's very important to consider what method actually you have to apply.
Yeah. Okay. I have two questions for you that I wrote it down. Have you ever got a chance to visit some of the pegmatite sites here in Brazil?
Yes, I worked together with a colleague,
Awesome.
Hartmut Beuren in Recife. So he showed me some pegmatites in Borborema, and also my colleague Santa. No, sorry, I forgot her name now. She showed me some pegmatites in Paraíba. So
Oh,
unfortunately, I haven't seen the Bahia pegmatites.
and you never actually saw the pegmatites around the state of Minas Gerais?
No.
Okay, yeah. The next question is consider the high exploration sites in the north of this area that I just said, Minas Gerais. The region it is called Vale de Jequitinhonha, and consider that we have here most of the pegmatites in the surface. Now we are starting to explore underground pegmatites. We have three big companies in the region. Um, what are your opinion on the exploration and potential of uh, Brazil and this change of energy transition? Can you say like what are your uh, thoughts or regards or anything about this?
Yeah.
Uh,
Okay, it's a bit difficult because I have not seen the Minas Gerais pegmatites.
Yeah,
So you have to
it's a little
consider,
bit different than Borborema, but
yeah,
they all beautiful.
yeah, I believe so. I mean, I've seen this mineral specimen.
Yeah.
Let's say you have to consider, yeah, first of all, also most people forget also the pegmatite size, you know, how big the pegmatites are. If the size are reasonable to do some mining. Of course, technology is changing. You may have can apply small scale mining simultaneously in a number of pegmatites in the same area, maybe with a flexible crushing plant as a movable, for example.
Mhm.
Yeah, regarding exploration, I don't know how thick the soil cover or the outcrop situation is in Minas Gerais. I think very bad. So uh, also the radioactivity which we apply in the Tüßfjord maybe not be applicable for the Minas Gerais pegmatites. Yeah, maybe soil sampling is one approach. Um and yeah, you have to understand, I think very important that I want to try to explain today with a new approach. You have to understand the formation of your pegmatite field in general. If you have your pegmatites are generated by a parental pluton, you may have a nice regional chemical zoning, which can you use to predict where the most fractionated pegmatites occur. Otherwise, you have to work out, maybe you can apply the quartz chemistry approach to get a regional chemical pattern of your pegmatite field to
Mhm.
understand in which area are the highest fractionated ones and where are the primitive ones. Yeah, and where you have found pegmatites which are suitable, the chance to find more in the same area are high. I mean, that is a old rule of mining or exploration.
Yeah. Um, um, I think I thought it was very interesting the model that you show of ground penetration radar. Here in Brazil, we don't have actually detailed um, studies of this type of technique, and I am a big fan of this technique. So I think we have uh, a big a way in a promising future of exploration and I don't know if we can have enough people to join and start studying. I think we're gonna have some interesting development and research. So I'm I don't think we have any more questions. And thank you again, Professor, for your presentation and your availability. And in the next, I think in the next hour, we're gonna have another presentation from a Brazilian research female person called Priscila Fernandes. She worked in the Geological Service of Brazil, CPRM, and she's going to show some of the research that she's developing with a group in the Borborema pegmatites. And if you want to, I don't know, to see as well, we can send you the link. And for everyone that watch, thank you very much, and please stay tuned for the next presentations. And yeah, thank you. Um,
Thank you
uh,
very much. Yeah.
ok. Uh, então, pessoal, muito obrigada pela presença de todos, muito obrigada pela participação. Como vocês puderam ver aí nos comentários, o link para o certificado já foi enviado. E como eu falei anteriormente, espero que vocês consigam, né, participar das outras apresentações. A próxima é às 15h30, da Priscila, e Amanhã, na parte da manhã, nós temos a continuação de alguns minicursos e na parte da tarde nós temos a sequência ainda de apresentações. And Professor, I forgot to tell you that I'm sure you already saw, but until Friday, we're gonna have in the afternoon at the time zone of Brazil a full presentation with different aspects. And in the morning, we are having a few mini courses. Uh, and again, if you want, we can send you all the link and everything. I want to say thank you again and see you guys in a few minutes.
Okay. Thank you again. Bye bye.
Okay, bye bye.